Hey, welcome to Adventures in Angular, the podcast where we keep you updated on all things Angular related. This show is produced by two companies, Top End Devs and Envoy. Top End Devs is where we create top end devs who get top end pay and recognition while working on interesting problems and making meaningful community contributions. And Envoy, which provides remote design and software development services on the most client friendly structure. So clients only pay after the tasks are delivered and approved. In today's episode, we will be talking about events, most specifically event sourcing, for those of you that may know the subject. And we'll be talking about the differences between what is considered event sourcing in the front end versus on the back end. My name is Lucas Paganini, your host in a podcast, and joining me in today's episode is also the host, Armen Vardanian.
Hello, everyone. Nice to be back for another one.
The host, Subrat Mishra.
Hello, everyone.
And our very special guest, Luis Galeas, which is the CEO and founder of Ambar. We'll be talking a little bit more about what Ambar is, but basically what you have to know is that he is really an expert in event sourcing. He knows a lot about that. And Ambar is a company 100% focused on event sourcing as well. So Luis, thank you so much for being here.
Yeah, hello everyone. Really great to connect with the front-end community. I'm Luis, founder and CEO of Ambar, but even though I'm the CEO, I'm very much an engineer. So looking forward to talking about a lot of software today.
Awesome. So Luis, I think just for us to get started and give a bit more context to the audience, could you do a quick pitch of Ambar and what it does, which problems does it solve?
Yeah, so when in front ends, to give some extra context, you have one place where you're doing things, right? You have the in-memory state that you have on Chrome or Firefox or wherever you are, or even if you're using React Native, even in your device. When you have a backend, you have multiple moving parts to that backend. And when you are registering events, you have to process them somehow. So that processing doesn't happen in a vacuum. It happens with a pipe in between different systems. And that pipe is really difficult to build. The way that you connect events from one place to another. And that's what we do at Ambar. We focus on making that experience extremely easy for engineers, where they just write a few lines of code, and then the pipes and the engines that move data around just come up magically.
Awesome. Okay. So now that we have this intro, I think we can start tackling the initial concepts that the audience must understand in order for us to go ahead with our discussion about events. So I guess the first major concept is, well, first, what are events specifically? Because talking with front-end developers, there is the native concept of an event, which is basically like you clicked on a button, so that triggered a click event, or you moved your mouse, so that triggered a mouse pointer event. So there's this native concept of events, which isn't completely different from what we're talking about here, right? But what we are talking about is a bit more generic than the native concept of events in the front end. And then after explaining the concept of events, I think we could also go to what is event sourcing specifically.
Yeah, so in the front end, like you were saying, you have these click events. You might hover over something, and you use that to build state, right? To build what your application looks like, to build HTML, load some CSS if you're loading it asynchronously. And all of this is done in a sort of flipped way from how you would have done it traditionally. And when I say traditionally, right, I mean like 1999, right, where you would essentially just define your HTML and that's your state, and you don't really have events. In event sourcing, to now go to event sourcing, it's kind of the same concept, but on the back end, where instead of taking the state of today's application, say you have a user with a username and email, you record your events. So you say something like, I've just signed up, or I have just verified my email, or I have just purchased an item, or we have just dispatched an item from the warehouse to this customer. And when you register these events, you are able to then rebuild your state later on from those events in the same way that you would in a front end. But obviously, the devil's in the details, because in the front end, all you're doing is you're building this ephemeral state of what I'm displaying in the DOM and the HTML, whereas in the back end, it's something that you need for your application to run.
Perfect. So it's basically the idea that like you may already be familiar with the flux concept. So in React, you might be using Redux, and with Angular, you might be using NGRX or some sort of state management library. And so if you already have this concept and you already understand what would be a custom event, and the idea with event sourcing is that 100% of your state is based on those events. So whenever you need to create the state, you just process the events, right? And you basically reduce the events based on the current state. So it's the same way in which we do it in NGRX and any of those state management libraries. But as you were mentioning in the beginning, when you introduced Ambar, when you do that in the backend, it's a lot more complicated, because you can't just have a function that takes the entire current state of the application as the first argument and the event as the second and returns the new state, because it's like the current state can be gigantic, right? So you're always trying to to make it scalable and make it as fast as possible. So that's basically it, correct?
Yeah, that's it in a nutshell. Yeah, absolutely.
Awesome. All right. So now that we got the concepts out of the way, can you explain a little bit more like the challenges that we have with handling events and event sourcing in the backend? Like, of course, there are those that we were just mentioning about the scalability, but I also imagine that sometimes you might want to deal with a small portion of the entire data, just because you also need to consider the effort to transfer the data from the database, right? So maybe like you have your entire state, but as you iterate on the state, you might only want to retrieve small portions of it to run your calculations. Also, there's the problem that everything is asynchronous. So these are just some of the things that are coming to my mind. But which are the ones that come to your mind in terms of the complexity of implementing an event sourcing system in the backend?
Yeah, so the big difference is that your state is not ephemeral. If you have a single page application on the front end and you just do a reload, you might just hit the backend endpoints again to get some state, right? And that's essentially your database, right? But there's not much going on in there, right? You might get some user details, you might get some cookies, some things, but that's it. And then you have essentially a clean rebuild if you're using these tools like Redux, where you have some state, you might have some events, and then if someone clicks, then you might return a new state. The difference in the backend is that you now have to have the state for all your users, so that you have a new state of the application at any given time, and have the ability to retrieve subsets of that state. So, for example, if I have a bunch of users that are signing up, I don't want to return to a user on a backend endpoint information about another user necessarily. I might just want to return information to them about them. And if I'm going to do that, I'm going to need to save those events somewhere and then have a way to execute that function in a cached way of sorts. So instead of recording the events and then getting all the events in my system and running them through a function, and every time I get an HTTP request on the backend, I return to them a result based on all the events in the system, what I would do is I would pre-process those events. So I would be building the state of the application on an ongoing basis, and then retrieving the state from somewhere dynamically whenever somebody makes an HTTP request. And that's markedly different from the front end when you at the beginning of the load, if you press F5 or reload, you fetch your state, and then everything lives in very much in isolation.
Yep. Yeah, that does make a ton of sense. Like the fact that you actually have the data of all the users, not just one. So that is indeed a gigantic complexity. Subrat, I noticed that you were going to say something.
Yeah. So yeah, I was just asking, like, just to be clear to me and for everyone. So is it so the Amber can be a use case in between your, like, suppose you are consuming to some services, some external services. Amber can be play in between your services and your UI, and to
Yeah,
handle the PI events. Yeah.
yeah, precisely. So the
Okay.
software we built is in response to this, the need in event sourcing in particular, where you need to communicate between different components, or sometimes you need to kick off an asynchronous process. So,
Mhm.
if you have a click event on the front end, you process it right then and there, right, in memory,
Yep.
right? That, fine, cool, done, right? But in the case of a sign up, you might need to send a welcome email, and you don't want to do that in the same request. You a day later, and you want to kick off a process that is asynchronous. And you might have sometimes where you need one service to understand that, hey, this person signed up, they have this hashed password that they stored in the identity service. I'm the authentication service or the API gateway, so I need to know what the hash password of someone is, and I need to listen to those events. So this whole produce, consume pattern, or publish, subscribe, when you're doing it on the front end, you can do it in memory, all of it in one place, where this queue of events is just one very big queue, or not one very big queue, but one very easy to process queue, single threaded. Whereas when you want to distribute things and scale them and partition them so that you can parallelize your work, doing that is complicated. So what we do is we act as a bridge where you say, look, this is where my events are being stored, and this is where I want them to be processed, and everything in between, we just make it work. So those pipes, as well as the ingress and the egress, we have that out of the box with correctness guarantees, and that's the premise of the product, that it saves you a lot of time from having to build those yourself.
So does this, like, the Ember also provide, like you said, just login, for for example, sending mails, forgot password. So you also provide some boilerplate event sourcing as well, or it's just you just pass the data and handle the data.
Yeah, the latter. So we have one laser focused goal of making that experience really easy, because people will have all sorts of different schemas, they might have all sorts of actions, and what we do is we give you a layer that allows you to simplify doing whatever action you want. Two things that engineers are very used to: writing to a database and responding to HTTP requests. Every backend engineer in the world can do those two things. So we are taking those as APIs, so that then if you want to send a mail, if you want to connect to MailChimp, if you want to connect to Snowflake, if you want to, whatever you want to do, if you want to connect to your own database, to another database, to a search database, all of that is up to you. But we give you the guarantees that you will get the messages, you will get them in order, you will get them in a scalable fashion. We will not bring your system down. It's obviously communicating securely. All of those things that normally take you months to do, we do them for you in 5 minutes, where you just say, this is my configuration, bam, magic, it's done.
I wanted to talk about the actual implementation more deeper, let's say. So we talked about event sourcing, and I have to confess that before our today's episode started, I didn't know what event sourcing meant, but when I read a bit about it, I understood that I kind of knew about it, I just didn't know what it was called. So, and I think this part will be also useful for the listeners. Let's just clear it up. I will try to explain what it is, and you, Luis, you know it better. Please correct me and let me know if that is correct. So I'll figure out if that
Sounds
is
good.
true. So yeah, essentially, it's a way of storing the state. And I'm saying it in an abstract way, it doesn't matter where it is, but usually, of course, it goes in the backend because you have a database. And instead of just saving your, let's say, current or latest state, instead of just having a database that says, okay, the user is this name, this last name, this password, and so on, you save snapshots of everything that has ever happened to a user, right? So essentially, you get events like change password. User changed password. That means something in terms of how the data changed. You have like the user registered, user disabled their account, and so on and so on. And you store these events. You keep them in this consequential state, so that you can sort of look up when what happened, right? And you can like reconstruct a situation of how the state looks. You can take a look at how the state looks right now, right? And you can also say like, what did this user look like 7 days ago, for example, before they changed the password or disabled the account and so on. Let me know if that's the correct understanding.
Yeah, that understanding is spot on. I think in practice it differs a little bit in that this time machine functionality, we don't use it as often. So people love talking about this one, and the reading material that you probably looked at, it's one of the things that everybody loves to preach about. But really need, right, is you need your current state. So there's no getting away from that. You still need to know what is someone's current hash password, what is someone's current username, what is someone's current email, how many products have they bought, what is their credit balance, their debit balance, those sort of things. But the advantage with event sourcing is that you can decouple all these concerns. So normally you would have one big user table that says this user has these properties, right? But sometimes they might mean different things. So for example, you might have what someone's email is and whether it's confirmed or not confirmed, right? Whereas if you have the events that say, hey, this person asked to register with this email and then they confirmed it, that information is very precise, right? And you don't have to have some weird interpretation of if the table looks like this, then it means this. So with event sourcing, you're inverting the concept of, you know, what's happening in your application from going to this really fuzzy way where you can't really distinguish what's in your data storage to being very explicit about what's happening. And the main function, of course, is to convert into current state, not quite to do this time machine kind of traveling. And that's good. You can still use it for that. And you can run some nice analytics on it, and it works out very nicely for that. But the idea is that by being explicit about what's happening in your application, it's a lot easier to reason about how to build that application. So, for example, if you are signing up and you want to have a store of what, you know, just a simple map of this user ID has this hash password, so that when you're doing authentication, you can just very clearly look, user ID matches this password. Great. If you have a table that has a bunch of other fields and that has different functionality in it, and you might have old passwords that you're storing in there just to check that someone doesn't sign up again with the same or doesn't change their password to an old password. If you're doing this kind of stuff, it gets very unwieldy when you have so many different functionalities and you have one big state and you don't know how to interpret it. Whereas if you're explicit about your events and you get it wrong, all you have to do is you build a new model that interprets those events and you say, you know what, I'm going to switch from this old model to this new model. And that's the big advantage with event sourcing, because it improves your system so that it's more understandable. And in turn, what that does is in the real world application, you as an engineer can go a lot faster because you don't have to understand absolutely everything. You just have to understand the specific feature you're working on.
My big takeaway from what you just said is that I don't need to store stupid Boolean properties to confirm if the user has this or that or confirms something. I just have the event. If there has been no event of, I don't know, disabling the account, then the user is enabled. Right?
Yeah, exactly. And you can, you can build those models where, you want to confirm what someone's current state is. So you can still build those. But events essentially help you make impossible states impossible, if I can say it like that. You know how sometimes you might have different Booleans, and this Boolean number 1 can only be true if Boolean number 2 is false, and you have this kind of weird state. In event sourcing, there's none of that where you have like some weird model. If you get your model wrong and you want to change it, you don't have to do a migration. All you have to do is you have to reinterpret your events. And because those events are really explicit, you're not doing silly things exactly like you said, where you have, a Boolean of whether this person is activated and you have to understand what's going on.
I can see that in a very, very small capacity in front end, for example, if I'm doing HTTP requests, and it's just an idea. I work with events, for example. I have report progress, I have error, I have loading states, and so on. And if I were just using Booleans, I could possibly have this impossible state of there is an error. I know a request is finished and there is an error. But for some reason, the loading Boolean is still true, which doesn't make sense. It's not loading anymore. There is an error. But if I interpreted it like a stream of events, like loading started and then you see this error or completion of the request, then it's not possible to have this loading true or whatever if you're moving away from that stuff. I'm not saying it's like literally event sourcing, but it's like the same idea.
Yeah, it's the same idea. So, I mean, if you think about the functions that you use in the front end when you're using this type of pattern with events, you always have to return some state, right? So you get
Yeah.
state into state. You cannot go from state into nothing, right? And if your state itself has a model that in the backend when you're doing event sourcing, if the state has something that you don't like, all you have to do is you have to take your events and essentially reinterpret them and say my new model for state is going to be this model. Whereas in the old way, you would have to migrate your old state into your new state by doing some sort of crazy contraption where you interpret that state as like, okay, if this boolean is this and this boolean is this, then this user is, and then you do this gigantic migration. It's really painful. You have to do it bit by bit. Whereas if you just have to rewrite the function that interprets state conversion from old state to new state, that's much easier to do.
This makes a lot of sense. I actually kind of like it. Although this does create lots of stuff in the storage where you store the events, right? It's way more redundant.
Yeah, you would think that that it is considerably more redundant, but in general, you get. I mean, it's really hard to give you a hard estimate, right? But I would say that your storage would go up by maybe 5 to 10x because you're now storing history. If you were in a position where you weren't previously storing history, but a lot of applications, what they do, they'll have a user table and someone comes in from compliance and they'll say, you know what, I need to have an audit log. And then what they do is every time the row changes, they store a new copy of that row. So now they have a table that has every single version of that row you've ever had. The problem is that now that pattern is considerably worse because now you're going to go from storing your state to every time the state changes, you're going to store your old state and your new state, not just the diff. Imagine if in a git commit, right, you were storing the previous code base every time. You don't do it like that, right? You store diffs every time. So in event sourcing, you're essentially doing a diff of every time that my system is changing with this differential event. And this means that even though, sure, you're storing the history, you at least don't store it in such a way where you're being redundant. So if you ever are in a normal application and you need to have some sort of auditability, your storage might go up by 100x. Whereas in event sourcing, maybe you'll get 5x to 10x.
I see. That it also is way more explicit, right? So if I were just to store the history of one row, there would be like a million ways of interpreting why certain data changed, right? So I don't know if the user changed their status or an admin changed their status or something else entirely happened. I just know that one row was true and now it's false, but it could mean a bunch of things.
Yep, exactly.
That's
And even if you knew who did it, you don't know the reason.
Yeah.
Also, another nice thing is the scalability benefits of event sourcing, because by leveraging events as your main source of state creation, then you can basically scale infinitely, because you start from the assumption that every event is immutable. Like, it's not like we currently approach state in the backend, which is there's the current state and we're always making mutations and inserting or updating or deleting things from there. You just think of, you have this long stream of events and they are in a sequence. I would say I would just be careful to say timeline, because Luis can tell a little bit more about that. Like, one of the common mistakes that people do with event sourcing is using a timestamp to determine the order of the event, because that actually can lead to issues. It's not, we can't 100% rely on timestamps, but Luis can tell a little bit more about that. But it's basically like you have this sequential list of events that are immutable, So you can store them in databases that are built to deal with the fact that the data doesn't need to be deleted or mutated. Like, of course, you want to have the ability of doing that in case you need to do a migration or something, but the database can be very optimized to for replication and reading the events. So that allows for a lot of optimizations, and then you can just listen to this database of events and create other and have other databases that generate what we would call queries. Like, they're basically views of your state that are optimized just for reading the state, and they are generated based on parsing the events that are relevant to generating that state. So it's very, very scalable. There are multiple ways of like, it's scaling your infrastructure to handle billions of users, but you also you lose a little bit of the, what would be the technical term? You get eventual consistency. Is that correct, Luis? So you don't get like something that happens immediately, but you know that eventually the state is going to be what it's supposed to be.
Yeah, so in distributed systems, so for context as well, my background is mainly in distributed systems and in backend. And when you are parallelizing some work, you cannot parallelize work that is acting on the same thing, right? So for example, if you're doing something like calculating the digits of pi, and you need to, your computation needs to be increasingly more accurate. Maybe a mathematician would correct me here. I don't think that there's a way to parallelize it. And if you are calculating, for example, a hash of a hash of a hash of a hash of a hash, you can't really parallelize that, right? Because you're acting on a single thing. So in event sourcing, what we do is we very explicitly say what our unit of parallelism is. So for example, if you have, it's kind of like an entity, but not really. We call them aggregates in event sourcing, but for the purpose of today, I'm just going to call them entities. And if you have an entity and you have events on that entity, and you are acting just on that entity, then you can parallelize the work across many entities, right? So one server could be acting even on one entity on its own. So when it's building a view model of the world, you have a single server processing a subset of the entities, and that means that the more servers you add, the more entities you can process. Now, something to note is that when it comes to an entity, you do get a consistency boundary there. So you can say, I'm going to do a transaction where when you're storing events, where I'm going to make sure that before I add an event to withdraw $200, I want to make sure that this person has deposited at least $200. And you can do that. There's a little bit of nuance on how you would do it, but you essentially can do that on a transactional basis. And you can also say, I'm going to transactionally do things between two different entities. But the important thing is that you have now made very explicit what your unit of parallelism is. So in a traditional system where you have state stored in some tables, you would have to figure out, how do I make my tables scale? How can I distribute this? How can I shard my database, right? And there are some solutions that help you with this, but in this case, you're making it extremely explicit. So it allows you to scale on the view side because you can build your view models in parallel, almost arbitrarily across however many servers you want. And then on the right side, it gives you a unit of parallelism where you have to be very explicit about what you're doing transactionally. And if you need to go even one level higher and scale the right side quite a bit, and we have this thing called event stores for where we store our events. If you need to scale that, then there are ways of sharding it, right? But the nice thing is that you're usually using the right tool for the job, because on the right side, you generally don't need to scale that much. If you're doing 10,000 events per second, like transactional actual events where people are editing their state, you're a really big company, right? And most companies, even I've worked with companies that are doing finance or logistics, even they don't have more than 100 events per second. So if they only have 100 events per second, they are completely fine with having a place where they store their events, which doesn't need, it's a single server, right? A single Postgres instance. But this might not be the case for their views. their views. They might have a lot of people viewing things all the time, fetching the current state, or they might be building new views and processing old events. That needs to scale, and in event sourcing, you separate it all together. But yeah, the system scales quite well from an infrastructure perspective. And the other thing, which I think is the unsold benefit, is that it scales from a team perspective, where because you're decoupling your system, people can work on different components without having to bother each other.
I think we could also talk a little bit more about which technologies actually are used for event sourcing generally, and how those things are wired up together. Like, I briefly touch on the subject of separating the querying and the actions, which I think is called the command layer, if I recall correctly. So how is that generally done, and which technologies are generally used? Like, I also mentioned that we could have a database that is optimized for storing and distributing events. Which databases are generally used? Like, what is the typical anatomy of a distributed system at a large company?
I love the word anatomy. It's so fitting. The typical, so I'll give you the components, and then I'll dive a little bit deeper into them. So first of all, you need web servers, right? You need web servers as the API for some front end, right? And you need a place to store your events, and you need places to store your views, your read models, we call them, or projections. And you need a way to connect the place where you store your events with the place where you're going to be processing to build those views. And so if you think of it as a chain, right, you have, first of all, you have the web servers, then you have the event store. Then after that, you have some sort of middleware connection with some queuing system that is then offloading things to the next part, which is the workers that are going to be building the view models. Then the view models themselves are different databases where you can pick whatever you want. And then the web servers, again, that were at the beginning, can access those view models. So in the first layer in web servers, you can use whatever you want. And any language that can connect to a database will do, and that can receive HTTP requests. On the database side, where you're storing your events, you normally go for a single leader database unless you need extreme scale. If you need and because they provide you some very nice transactional ways of doing things that you don't have to implement yourself if you're using NoSQL. So for that, you would use MySQL, Postgres, SQL Server. There are a couple of event sourcing databases that are just specific storages for event sourcing called EventStoreDB and Axonic. There are a couple of libraries as well that you can take to make Postgres look more like those databases. In my experience, I haven't had a need. In fact, if anything, there are a couple of missing features out of the specialty providers. So I tend to steer for using Postgres first, MySQL second, and then SQL Server if it's a Microsoft shop and they love using everything Microsoft. Anyway, so that's on the event store. On the worker that is going to be consuming from the event store and putting things into a queue, again, it can be anything as long as it can connect to a database. For the queue itself, you would use something like Kafka or RabbitMQ. The problem with using something like RabbitMQ, and it's a warning I give people, is that RabbitMQ is ephemeral. So if you want to reload your events and process things from the beginning of time, you have to go bother your original event store, which is why I recommend having a queue that has non-ephemeral storage. Kafka works really well for this, but it is very painful to set up. That's why we build the company, right? And then you have the layer that reads from the queue, and you would have a worker there as well. And for that, again, anything goes. And what our job at Ambar has been, right, is to take those three middle parts, the worker that is reading from the event store, putting it into the queue, and the queue then takes it to that other worker that is going to be doing some processing. We abstract those 3 points, right? And then for the read databases, you can have anything you want. You can use Postgres, you can use Elasticsearch, you can use DynamoDB. In general, for the views, I recommend using NoSQL, because in the views, you want to be able to rebuild them really quickly. So if you make a mistake and you want to release a new bug fix, and you're processing your events from the beginning of time, you want to be able to do that in parallel. And if you do it in parallel, but your database is a bottleneck where you're storing your views, then that's problematic. So if you choose a NoSQL database and you think about consistency as well and about doing things in a transactional way wherever you need, then that's fine. The database is going to work. It's going to scale. I tend to go, so if I were to pick my ideal stack, I would pick Postgres for storing events. I would pick DynamoDB for storing my views. And then obviously I'm biased, so I would pick Ambar in the middle. And if you have to know what we use in Ambar, because Ambar is obviously not just a magic box, our connectors are written in a Rust and Haskell stack, and we use Kafka as the middle layer for the queues. But I think that the simplest way to do this, like if you're using Ambar, you essentially now only have to pick your place where you store events, your web server, and your view model storage. Where I would pick Postgres, my favorite language for backend, and then I would pick a database for the view models, which would just be DynamoDB.
I think it's interesting that you mentioned that there is a database that is dedicated just for event sourcing, which is EventStarDB, but you actually don't recommend using it. Why is that the case?
Yeah, so it's because it's so. As engineers, I think it's a good product, but as engineers, we tend to use the right tool for the job, and the right tool for the job sometimes depends on what we know. And I understand traditional databases quite well because I have a very hefty computer science background, and there are capabilities that I don't have with EventStoreDB. So it's more because one, I know how to do things in traditional databases, and two, because there are some missing capabilities. So the event sourcing world can be quite dogmatic, where if you go into the forums or the Discords or the Slacks and you ask people questions, they will tell you must only do it this particular way. However, in practice, right, as engineers, we need to make trade-offs, and everything's a trade-off. There are no silver bullets. And the problem with an database that's specialized in event sourcing is that they make a lot of those decisions for you. So if you ever need to break the rules and you know why you're doing it, and you know that in this case, actually, it's better to break the rule, because if you don't break the rule, it's going to be much worse, then those databases don't give you the flexibility to do that. And it's why I don't like the set schema, the fact that the APIs are meant to work a specific way. I cannot do a transaction with a separate table, and these type of things steer me away from a custom specialized database for event sourcing.
Gotcha. Okay, so it's not that it's a bad choice, it's just a bit too opinionated, and also you have all this background that allows you to do whatever you want with the more general database.
Yeah, right. I would recommend for people that don't have the background to grab a nice library. So there are some nice libraries out there that will wrap things like Postgres or MySQL and give you something off the shelf where you don't have to figure out the schema. And also, to be fair, if you are going to be doing event sourcing, instead of going for something that's like super opinionated, and then you say, you know what, I'm not going to learn about it because I'm just going to use the opinionated tool, you're still going to make mistakes. So it's better to get the extra education. And then in that case, you're probably going to want to do your own schema anyway. So big word of warning here, event sourcing is not a silver bullet. There's a lot of knowledge that you need to implement it. It helps a lot once you get that knowledge, but you should get that knowledge.
Okay, that makes a ton of sense. Well, we are... Yeah, sorry, go ahead, Subrat.
No. I was asking like maybe a practical question. Suppose someone has a small or to a mid-level e-commerce. I'm just taking an example of e-commerce application, and they have already built it. And they want to scale because they are getting some traffic and all. So according to if they want to now migrate from traditional way of handling data to event sourcing, like approx how many days or how many months it should take them to?
Yeah, so it is a big migration. Again, I'm an engineer, right? So even though I'm the chief salesperson of the company, I'm very realistic. I don't like overselling concepts or tools. I want to give you the real deal. So look, the way that you would do such a transition is you would do it piece by piece. So you would move the first piece over. If you have tools out there, like if you're using things like Ambar and you have a good library for Postgres and you have some good practices internally already where you're deploying infrastructure as code, so you already know how to use Terraform, and you have some base knowledge, then adding event sourcing to a specific part of your application, like to your to your order tracking, for example, this should be relatively simple. It should be something that you can get done in 2 or 3 weeks with 1 or 2 people, if you know the theory, right? The education part takes a little bit of time. I would say that for someone who's starting from scratch and they have some backend knowledge of how databases work, and how web applications work, in maybe roughly 2 or 3 weeks, they can get to a very good position, where if they've been, obviously those 2 or 3 weeks, you could spread them through the year, right? But it takes about that long to get into shape, right? So if you don't know anything about event sourcing, you're just coming into it right now, and you need to move the first part of your application over. It's going to take you 2 or 3 weeks of education and maybe another 2 or 3 weeks of implementation just to move one part. And thereafter, you can start moving the other parts.
Yeah. Yeah, completely makes sense. Like if you have a microservice, maybe just pick one part of that microservice and slowly cover all the services.
Exactly.
Yeah. Makes sense.
Awesome. We are approaching 40, 45 minutes, and I want to make sure that we are covering the most important pieces of the subject, because this is way too extensive. Like, this could be an entire course instead of a podcast, which, by the way, it is a course. So Luis, maybe you can talk a little bit more about that. But I'm thinking I would like you to tell a little bit about the course that you guys have about event sourcing for those that may want a deeper dive into that. And also, if there's anything that maybe we haven't asked and that you think it's really important that you want to touch upon or talk about for the audience.
Yeah, so I think I've mentioned a few of these, but I would like to put them together in one place. So in event sourcing, we have benefits and we have drawbacks, right? The benefits are that your application is much more auditable. It's a lot easier to debug things. It's a lot easier to fix the bugs. It gives you a lot of flexibility when your requirements change all the time. It can model really complex domains, and it's much more explicit about how you're writing your application. It's easier to understand, but there are drawbacks. And the drawbacks are that you have to learn and you have to unlearn some things as well. So you have to know new patterns. You might not be able to get your team on board with this concept. And you have to convince people as well of using it, and you have to explain your reasoning why. And furthermore, the community is quite small at the time. So, if you take something like React or Angular, you have so much attention over the world over these topics. Whereas for event sourcing, it's a much smaller community. Like we have, there are no specific event sourcing conferences really that happen on a yearly basis. Sometimes some people organize some, and you might have a couple of books here and there that reference it. The best material on event sourcing out there is spread all over the place, and that means that if you want to get into event sourcing, you have to be a bit like Luke Skywalker in Star Wars, right? That goes and finds this little green man in the middle of nowhere and asks him a bunch of questions, and then finally learns the ways of the Force, right? So it's a bit like that, and that experience is not great. And that's actually why. So this is a nice transition to the course, that we think that there's a big need in the community to put everything together in one place and allow people to ask questions on a very ad hoc basis where they might be struggling with one part or another. So we put together a free course because we're really invested in this community. And essentially people just take a week to go through it. It's 1.5 hours in the morning, 1.5 hours in the afternoon. And after 5 days, you get to be in a very good place. And we have a community as well on Slack where people can come in and ask questions. But I don't want to oversell just all the benefits. I want to mention that it does take work to get onboarded, and it does take a little bit of perseverance, right? It's not simple, and we want to make this better. And tomorrow we want to make it a world where you can get started with event sourcing in 5 minutes, but that's just not the reality today.
Yep. I love that, by the way. I love the fact that you guys offer this guide for people that want to learn more about it. I myself have tried to learn event sourcing for so many years, consumed so much content, and still, when I did the course that you guys have, it was such a big difference from my previous attempts of learning it. It's just there is no direct comparison, honestly. And the fact that this is at least currently offered for free, which I personally don't think it should always be offered for free. I think it should eventually start charging for it because it is a lot of valuable content. But yeah, the fact that it is currently offered for free is such a gigantic opportunity. Anyone that currently wants to learn should definitely check it out. By the way, how can people apply for that? Is that still open for people that want to join?
So our domain is Ambar Alpha Mama Bravo Alpha Romeo .cloud. And then the link for the course is just ambar.cloud/ESC, where ESC stands for Event Sourcing Course. So if you just head to that page, there's a registration. The next session starts next week, and then the one after that. And we run it in 2 time zones so that people from all over the world can join. So that's for free. I think it will remain free for as long as the company remains small enough that we can afford to do it. I think at some point we might change it, but the benefit is that we are also getting customers out of it. So they're doing event sourcing. They come to us and they figure out, oh my gosh, these people really know how to do this stuff, and then they use our technology. And obviously we make money out of that. So we do it out of the kindness of our hearts as well, but because we're also interested in getting customers eventually. So I think it'll be the case that we get enough customers out of it to make it worth our while. As long as we keep getting customers out of it, we'll keep it free. And it might be that means that it's just free content forever.
Awesome. Well, let's hope for that. All right. Guys, Armen, Subrat, before we wrap up, do you have any specific questions you want to make for Luis?
Yeah, I was just thinking I will join the course.
Great.
Maybe in the next this one.
Fantastic.
I would love to say the same, but I'm swamped with different stuff. But I will definitely look into it because at least the approach, I'm not working on the back end, but I can see how this approach, this mindset can help solve lots of problems on the front end too. I was just thinking on the top of my head, what would I do if, for example, I had state management and tried to implement undo, redo functionality on a bigger scale. Like I have a form that has important stuff and I want to be able to give the user the ability to kind of like revert back, see what they did, maybe see a history or something. And I feel like storing the snippets of changes and using RxJS powers you can really simplify your code. I've read articles where people implemented like undo redo functionality or stuff like that with NGRX, and it was lots of ugly code. Because instead of thinking in terms like storing the history of changes, it was more like, well, every time the state changes, let's pick that snapshot, put somewhere, pick that snapshot and put somewhere, and then the random access memory is also not infinite, so it would probably be better if we could find sort of language to use in those situations. And this would also allow me to kind of keep in sync with the server. When you like go on Google Docs, you type a bunch of stuff, and then on the top there is an icon that sometimes synchronizes with the server and says that, okay, this is stored in the Google Drive, right? So that functionality you also can do. Like you can find the latest snapshot that went to the backend, and in some time frame you can just pull the other history and send an update to the backend. So there's lots of stuff. You can store it in the index DB so the user can have undo redo functionality even if they like close the page and reopen it. There's lots of stuff that this mindset, I really like it. I've never tried doing it in my projects, but it was really fascinating. So thank you for shining some light on this topic.
Great. Glad you enjoyed that.
Awesome. Okay. So let's start wrapping up. Before we finalize everything, let's just do a quick round of promos. So I'm gonna go first with just promoting the producers of this podcast. So I'm going to promote Top End Devs and Envoy. So if you're interested in other podcasts about technology, maybe not necessarily just Angular, but front end in general, or maybe even React, and other subjects that might be more in the backend side of things, definitely do check out the catalog of podcasts in Top End Devs. And if you are a company, or you are working at a company that is looking for more developers, that needs help to develop the system faster, or is just swamped with a lot of things, then definitely consider reaching out to Unvoid. It is unvoid.com. They're basically offering remote design and software development services, but in a very, very client-friendly business model. So definitely check out that if you or someone you know is looking for similar services. Armen, how about you?
If you have been listening to the podcasts and previous episodes where I featured, then you probably heard that I wrote a book on Angular with the Manning publication. With all the new stuff going on in the framework, we figured out it would be great if there was a sort of handbook for Angular developers, especially the ones that, for unfortunate reasons, were stuck on older versions and have issues and don't have much experience with the new things because they work on older versions. So that's why I wrote Modern Angular. It's available in early access now. So if you purchase the book, you will get the ebook, and in the future, when the book goes into print, you will get the print version if you buy that option. And I'm happy to say that we are finally in the copy editing phase of the book. So now the copy editors are going through the book, fixing out every little bits of grammar and text. And we have done a couple of chapters. So hopefully in several weeks, the book will finally go into print. And I myself am very eager to finally hold it in my hand. And hopefully, if you haven't checked it out, we'll leave link. I'll be happy if I learn the book has been helpful to anyone.
Awesome. How about you, Subrat?
Yeah, I would like to promote my channel, which is Fun of Heuristic. Please go, guys, and watch that.
Okay, which, by the way, also has a lot of content about Angular. So it's a very Angular-focused YouTube channel for those interested. And Luis, how about you? What's gonna be your promotion?
You know, I would tell you that you can go and use our product, right? But look, ultimately, I am focused on giving value first. So even before telling you, look, go give us some money and use our cloud service, no, take our course. It's nice to meet people face to face. I'm still one of the instructors sometimes. You can find the course at Ambar, ambar.cloud/ESC. And I would love to see people there. And it's free. So, you know, you can buy our service later, but take the course. The course is free.
Awesome. Okay, man. Guys, thank you so much for being on the show. Luis, thank you so much for your time. This was really great. We talked for almost an hour, and honestly, we didn't even scratch the surface. I definitely recommend anyone that is interested in diving deeper to check out the course. If you're listening from YouTube, then there's the comment section, and we left a link to the course. But again, is ambar.cloud/ESC. So definitely check out that if you're interested in learning more about event sourcing. Again, thank you so much. And for those that stayed up until the very end, thank you so much for your time, and I will see you in the next episode.